So welcome to the final session of the night, the final panel, which is going to be about education in STEM. I'm again a huge fan of that. I learned the biggest piece of wisdom I ever had about education in STEM was this one. If you're cold, get a science book. You'll still be cold. You'll have a science book. And I think, that says a lot. So I'd like to thank the panelists for joining. I'm going to get them to introduce themselves here just for a couple of minutes, and we'll have a bit of Q&A just like before, and then turn it over to audience questions. I'm going to start with Zach Weiss. Would you please take the floor?
Hi. Hi everyone. My name is Zach Weiss. I am currently a senior at UT Austin studying aerospace engineering and incoming propulsion test engineer at a company called Relativity Space, which we'll go over to a little bit. So, just to contextualize what I do. This right here is called Terran 1. It's the first rocket made by Relativity Space. It's technically classified as a quote, light launch vehicle in the system of space launch vehicles. It is currently sitting on the pad at Cape Canaveral waiting for a launch date, which should be about any day now, actually. So in the next couple of weeks, keep your eye out on the space news for how the first launch of that goes. This Relativity gets this rocket is it's about 85% 3D printed, which is the main attraction of Relativity. It's to design 3D printed reusable rockets. I do not work anywhere close to the printers, disclaimer. So, this is what I work on. Specifically, Terran 1 starts with 9 AM1 engines on the first stage. Each of these engines produce about 23,500 pounds of thrust. And as you can see, with a person for scale, we're working on a single engine. So because of the expense and the cost and the difficulty of everything associated with space, we want to make sure that everything functions perfectly, which is where you get to what I do. What I do is this: I test rocket engines to design before they go to space, especially because rocket engines are one of the most unpredictable pieces of technology ever invented by humans. They can work perfectly one day and be completely non-functional the next. You get all sorts of fun and wacky combustion instabilities with special names like chug, buzz, hard starts, etc. And I specifically build test stands to test the engines on. I work on ground support equipment. The question is, how did I get here? I'm actually an alumni of Vandegrift High School. I graduated in 2019. I have spent since then I've been at UT Aerospace Department, where I work on the Texas Rocket Engineering Lab, which is one of a fairly small number of labs in universities around the US that's working on liquid bipropellant rockets, which is that first test of our engine, as you can see in the bottom right picture. And so that experience building a stand for Trell helped me get into building stands on a larger scale for Relativity. So that one on the right is the one that I worked on, as well as you can see in the render, the expansion at Stennis Space Center that we're working on. And I've also had a hand in designing a lot of those stands as well. So, as I would assume, probably the most inexperienced of the panel, I don't have a lot to offer in terms of, I have very little actual industry experience, but what I do have is a very good knowledge of how to break into the fields of specifically aerospace, but anything engineering for the first time as a college student, and also what you can do in college and in high school even to prepare yourself to be an excellent engineer or a scientist or anyone who wants to work on really, really cool stuff like this. Alrighty, thank you.
I think next, I'll yell. So for the guys in the back, I'm going to yell, all right? Next is Dr. Marion Gehrman, who some of you may know as a science teacher here at Vandegrift High School. Please go ahead and do your thing.
Hey, hi. welcome to my workplace. Okay, I actually was born and raised in Switzerland. This is actually my hometown, so that's where I went to high school. After high school, I went to University of Bern, which is also in Switzerland, where I graduated with a master's in chemistry, and then I kind of got recruited to do my PhD at Carnegie Mellon in Pittsburgh. So I actually made the jump and I moved to the States. The plan was just to stay here for like 5 years and then go home again. But I met him. So I got stuck here. So I then went to the University of Maryland, where I did my postdoc. And then I took a little bit of a hiatus. I had a family. I kept my foot in. I kept on teaching, tutoring, whatever. But now I'm here. I'm at Vandegrift and I'm teaching chemistry. So next slide. So how do you become a high school science teacher? Well, generally actually just need a bachelor's degree, right? Not necessarily even in science, that's preferable, but actually any kind of bachelor degree will do. And normally you need some kind of teacher preparation program. So if you go to university and you want to become a high school teacher, they offer that right there. If you go to a university and you have no clue what you're doing and you just get your BA or BS, and after a while of working somewhere, there are alternative programs to certify you as a high school teacher. Another way of becoming an educator in science would be a college or university faculty teacher. And that's actually the path I initially was on. Okay, in that case, you need actually a bachelor's degree, and most of the time you will need a PhD in a specific STEM field. And then you normally do a whole bunch of postgraduate research, because when you teach at a university, you don't get a whole lot of funding for teaching. You actually get your funding for your research, and you teach on the side. So if you actually ever go to university, you will notice that some of your professors really don't care about teaching, because what they're interested is your research, or their own research, and they have to educate you on the side. So hence I decided, you know what, I really like teaching, and I want to teach students, so hence I went back to high school. Okay, so what is so fun about teaching? Well, first of all, chemistry is just fun, right? You get to cook stuff, you get to boil stuff, 8 bubbles, it blows. The other day, an experiment caught fire, yay, that was an excitement. So yes, no, chemistry is just fun, right? But in general, teaching is fun. The fun part about teaching is that you can inspire other people. Like, learning is amazing, doing stuff is amazing, but the older you get, the more you feel you find your satisfaction if you actually get to see somebody else to grow, and that you can teach them and help them in their growth. And so that's pretty much what Albert Einstein also said. It's the supreme art of teaching to awake joy and creativity and expression and knowledge. And also, it's fun to see, to push a kid who actually thinks that they're not really good at STEM, and you can push them beyond what they think they can do. And then they succeed, and then you look into their face and they're like, I did that. And you're like, I did that too. Okay, common misconception about STEMs. Well, STEM is only for students who are planning to be engineers. No way, right? There's lots of different things you can do in STEM. And STEM is not only for the smart kids. That's another misconception. If you're not smart enough, I can't do STEM. Anybody can do STEM. It's about your curiosity, right? And the last one, of course, is girls are not good at STEM. When I started university, I was the only girl in my chemistry class. Now, look around. There's tons more kids or girls going into the STEM field. So, no, girls can do STEM too. And then I was asked to describe STEM in one word. yeah, that's what I came up with. So, I did describe the code.
So clearly, counting is not her beat.
Thinking outside the box. I love it. All right. On? Okay, sorry. My name is Cynthia Ortega. I'm an engineering software program manager at Apple. And what does a software program manager do? Well, one of the things that we mainly do is large programs. Our Apple Wallet is one of the things that I program manage, and it's anywhere between 8 and 16 different teams that you have to manage inside the company just to get a project out in the wallet. I just thought about something. I'm not used to Google. You have to save, don't you? Yes. No. Oh, I didn't save the slides when I closed them out. It should just be there? Okay. I had to ask my 8th grader to help me with the slides because I'm so used to a Mac. Yeah, no comments. No comments. Gallery. There we go. Oh, okay. There we go. So how did I get on this trajectory? And I started with STEM camps. Take as many STEM camps as you can. They're a lot of fun. They're things to do over the summer, and you don't have to actually take them in an area you think you will get your degree in. Just get as much exposure as possible. And then I also was in the IB program at my high school, and taking IB classes really helped me because I love the way the IB curriculum is and how you think, because it's not just straight memorization for learning. You really dive into things. And then of course, UT Austin, and I took a different route. I am not an engineering degree. I have a business degree with a manufacturing concentration in manufacturing engineering. At the time when I was going to UT, they didn't have industrial engineering, and I think only A&M did. So I was like, well, I'm not switching. So I stuck with the business school, and so my degree is a Bachelor of Business Administration. But these are all the different roles I've had throughout my career, and this is my career path. When I first started with Applied Materials, I was a quality intern, and it wasn't even like a cool internship, but it turned into one because I was able to interview lots of people throughout the company, because the task I was given during this internship was to, maybe I'm too close. How's that? Is that better? Okay, is that better? Yes. Thank you. Sorry. Okay, so one of the things the task was for the entire internship was to develop a catalog of all the testing modules they had on the manufacturing floor at the time, and the different tests that were for those modules. Well, I had to interview all the different workstations and the people leading those workstations to put this testing catalog together. And I got to know a lot about the products, a lot about what they do, how they test, the 5 different divisions. And so it was a really interesting internship in the end, but when I first got it, I was just like, how much do you pay an hour? Okay, great, I'll sign up. And you're okay with non-engineering degree? Okay, great. And so I just showed up, and I wasn't sure if I was gonna like it, but I loved it. And so I ended up spending the next 13 years there at Applied Materials for my career. And I supervised manufacturing floors for different modules. I ended up being a manufacturing engineer. So after having so much experience there, I was an actual engineer for 3 years before moving into project management roles. And then I became a vendor manager, materials manager, and then I made a leap, stayed in manufacturing, but went to ATM manufacturing. So that's that second picture there, and that's where I actually learned software. They had hired a lot of bank tellers to manage their their manufacturing deployment, but they started having problems with software. And they just said, well, okay, you were an engineer before, you take the software projects. Okay, again, I didn't know anything about software, but I started learning, started interviewing people, started asking questions, and I am now in a software career. So it's not about, not knowing something, it's about, are you curious, just like you said? Are you able to go the extra mile and really dive in and get to know what the problem is? And then, I went into mobile payments for the Android, which I don't have that picture up here, but I spent 3 years doing mobile payments for the Android, and that's how I got recruited by Apple Pay. And so Apple Pay recruited me to go work in Cupertino for 4 years. And those are some of the things I've done, but the most recent is the driver's license in the wallet. And that's the one that took 16 different engineering teams across Apple, all over the world, all different time zones, to be able to put out a product of provisioning, just like you have a credit card. We don't have it today yet in Texas, unfortunately. But in the state of Arizona, Colorado, and Maryland, you can take your physical plastic driver's license and provision it into your Apple Wallet. So coming sometime in the next 5 years to Texas. What is the next slide? Why do you like STEM things? I love STEM things because it really is like solving a puzzle. Sometimes the puzzle is great and beautiful, sometimes it's broken. But it's solving a problem. And sometimes, our problems involve privacy, because privacy is big for Apple. Security, legal even. You step out of your comfort zone and you get to talk to all these different people within the company, which is amazing and I love, and I never thought I would be doing something like that with a business degree in manufacturing. The next slide is about misconceptions about STEM. You have to have a 4-year degree. That original slide with applied materials, the test engineers at Applied Materials have anywhere between 2 and 3-year degrees, and they are earning 6 figures. So you don't actually have to have a 4-year degree in some cases. Some of our test engineers at Apple don't have 4-year degrees. They come from the Genius Bar in stores, or they took coding classes on the side, they took automation classes. They were really interested, and we pulled them out of the stores because they had so much experience with the products. The next misconception is STEM is just for boys. As you can see, no, it's not. I can't be good at STEM classes because I have ADHD and I can't focus. No. At Apple, we have a huge box in the middle of an executive conference room with different fidget toys, because fidgeting is creative. It stems creativity. My youngest will sometimes not look at me when he's talking, but he's really paying attention. And so ADHD, it's okay. It's a superpower. And I'm ADHD, that's why I put it up there. And that it's boring. It's not boring. And I think I'm going to show you the next slide why it's not boring. Because my one word was versatile. And why is it versatile? Makeup companies need chemical engineers. People who build amazing bridges are civil engineers. That wallet up there, that's the interface you see in your phone. That is not developed by just front-end engineers or client side. It is by human interface engineers who have degrees in art, psychology, sociology, human development, no engineering background, but they interface with the engineers, and that's where art intersects technology. And then the bottom two, of course, manufacturing ATMs. You don't have to have an engineering degree. Part of the design in the wallet is based on user research and user design. And then oceanography down at the bottom. One of the summer camps that my boys participated in when we lived in California was a oceanography summer camp. They loved it. but it had nothing to do with, basic engineering. So that's about it. Any questions?
I'm gonna go over here so I can use this mic, and you guys can share the other mics. Well, thank you everybody for those great introductions. So let me start with you, Zach. Now we heard from our buddies at Motorola a really interesting point that I thought was very germane. You are the folks in this room are going to be dealing with technologies that don't exist yet, and the technologies that do exist today will be obsolete. For example, AI. We've seen a lot of buzz in the media about AI destroying industries, taking away jobs, removing people's ability to do things. What advice would you give to students who are trying to learn to get into STEM in a world like this, where whole technologies are going away, whole careers are going away, and the future is unwritten?
Sure. So I guess this ties into what you actually learn in an engineering degree. And so what you learn in an engineering degree isn't necessarily, the most important thing at least, is not like the facts or the equations or even the discipline or even the specific disciplines that you learn. In my opinion, what engineering is, it's a process to solving problems. What you have to do is you find a problem that's unsolvable. You make assumptions to simplify the problem so that it is solvable. You use analytical relations and past data and what you already know to solve this problem. Then the most crucial step is you have to go back and check if those assumptions that you made were valid. So ultimately, engineering isn't about what you're learning, it's a problem-solving strategy. And that same problem-solving strategy and those ways of thinking can be applied in any industry. So as jobs disappear, for what it's worth, I don't think AI is going to kill very many industries soon. It's been widely overblown in the media. They're very good. AI is very good at imitation of what it's previously seen, but not yet original novel thought. I think it will definitely change the way that we approach industries. But digression aside, even with all these industries growing and changing and dying off and new ones starting, I think that what you learn in an engineering degree, or really any STEM degree for that matter, will still remain valid because it's not about facts and figures, it's a problem-solving process.
Thanks, that was a tremendous answer. My next question is to Marion. You deal every day with young, confused people trying to figure out their way and figure out their direction in the world, start their journey. What would you tell someone who's kind of on the fence about STEM? How would you coach someone who's questioning a future in STEM?
Yeah, I actually have quite a few students who come into chemistry not thinking they're going to like it. And then actually they discover that it's not that bad. And I have discussions with them. Hey, maybe next year you want to try it, maybe in an advanced class because you're actually really good at it. And they're like, yeah, are you really thinking I'm good at it? And I'm like, yeah. And they're like, yeah, I actually didn't think I was going to be good at chemistry, but actually I am, right? And so it's actually quite inspiring to see if you encourage a kid just to try something out, even if they think they're not actually going to be good at it, and then they actually discover they're not that bad. So as an educator, for me, it's any child has a potential of being great. They just don't know it yet. So any way you can approach a kid, or maybe they have a different approach to learning the subject, right? Any way you can make it approachable to them, and then they have that one first success, and they're hooked. Because the curiosity, that's just some inbuilt in somebody. So once that curiosity is lit, and they have that self-confidence now that they actually are not that bad at something, they may actually give it a try. And then you kind of encourage them and say, look, you don't have to become the PhD scientist, right? You just take some STEM classes and take your art class, and maybe something completely new comes out of it, because you can combine art with your STEM class. So yeah, just kind of like give students self-confidence that they actually can do this.
Thank you, Marion. And now, I guess a final question from me, and then we'll take some from the floor in just a minute. Just hold that thought just for a moment. Cynthia, just I guess a question for you. You've had a long and storied career with some pretty impressive history. Sticking with the theme of kind of education and young people, what advice would you have given yourself as you started your career that perhaps would have helped you along the way?
I would say one of the things is don't be afraid to do things that other people don't want to do. Because in the end, you take it on and you become the one who solved the problem. You become the one who was challenged enough or had the confidence to take it on, even if it was something that was hard to do. Those are the things that if no one else wants to do it, trust me, it's hard. And guess what? You don't have to completely succeed at it, but the process that you go through, what you learn through that process, how you present yourself, how you solve the problems, that is what shines, and that's what people will remember. I don't think it's necessarily whether it succeeds or fails. I was in one company where this one guy was the lead PM, and for some reason he had 5 projects that never made it to market. But he was a great PM, the lead PM, but something along the way, externally, was always canceling the projects that he was on. And he was on his 5th project, and again, it was canceled. So he spent maybe 4 years there on 5 different projects, and none of the projects ever made it to market. But along the way, he had great experience, and he was the lead PM.
Thank you. That's great insight. Appreciate that. We have a few more minutes left before we close out for the night. So let's take some questions from the floor. I think we have one back there. Go ahead.
Yeah. Is there any classes that you think you should take in high school if you plan on pursuing a STEM field in the future?
That one. Yeah. Yeah, I was definitely would comment on that. Okay. So first of all, just a thing. It depends on where you're going. I would definitely recommend AP and IB classes. It depends on where you're going, on what they take. What I do know is if you go to UT and do an engineering degree, that your AP classes will transfer and a lot of your IB ones will not. So because they're not directly applicable to a course in the UT curriculum. Things I would recommend you take if you want to go into STEM and engineering, take AP chemistry. That will help you. Pretty much every engineering requires at least 1 chemistry. It'll get you, and so taking a chemistry, AP chemistry here will get you out of at least 3 or 4 hours of credit of class in college. Take AP Physics C. Like 100% recommend this one because passing both tests, both exams on AP Physics C will get you out of 8 hours of class total, which is 2 3-hour classes and 2 labs if you go to UT. Calculus, AB and BC is also another one. And for your social studies and your histories and your Englishes, I would recommend actually taking them at ACC because an AP one at taking an AP class here will count for a single course. 1 year of an AP course here will count for a single course in college. But 2 semesters of ACC courses will count for 2 courses in college. So I would definitely recommend doing those 2 through the dual credit program. In general, though, what I would recommend with your APs, IBs, ACCs is when you get into college, a lot of counselors will try to tell you like, oh, are you sure you don't want to retake that one? Like, are you sure you to get a good foundation on it in college? My advice to people in all situations is always take the credit and run. The reason why, your professors don't trust any of your previous professors any more than they trust your high school teachers. Which means that if there's anything that you really need to have learned from those previous classes, they will cover it and they will go over it when introducing your new material. I think, and definitely just load up as many APs as you feel comfortable with here and as much dual credit as you feel comfortable with here, because this will reduce your stress level by a lot in college and or free you up to do things like internships and co-ops and still graduate in 4 years. If I hadn't taken as many classes as I did and got as much credit as I did going into college, I wouldn't have been able to take a semester off to intern for Relativity and still graduate at the end of my 4 years.
Thanks very much, Zach, for a panel on education in STEM. It's a great list of ways of avoiding education in STEM. Marvelous. Any other questions from the floor? Yes, question over here.
So, you've all been through some form of higher education. What would you say are like some main differences you feel you go through when you go to a higher education level? And do you have any advice for anyone trying to get into higher education?
Marion?
Okay, with the most degrees here, yes.
More
That
degrees
I-
than either of us combined.
More degrees than a thermometer, I think.
Yeah. Well, that keep me warm. No, okay, so yes, I collected my degrees because I just had fun learning. I didn't actually really care where they get me. And that's a typical thing, I think, for somebody who's really interested in STEM. I'm not really good in economics. I don't care about money, which is a bit of a drawback, right? Because I just like learning. So the different level of learnings, right? So going for a master's or a PhD, is it worthwhile money-wise? Sometimes not, right? You spend a whole lot of time for very little money. So I mean, I got paid for my PhD, but you don't get paid very much. But I don't care. I have fun because I got to do stuff. I spent nights in my lab. I mean, it sounds really nerdy, but actually it was fun because all my friends did the same thing. And I had freedoms that later on in life, once you have family and bills and a house to pay or whatever, you don't have anymore. So honestly, if you can and you're interested in, I would say go for it, because those years, they were actually the most fun years I had. Because I had no responsibilities, I just could learn whatever I wanted to learn, and my research was like, I could do whatever I wanted to do and explore, and it was fun. Do you get a return money-wise? Probably not, no. So I would say if you have fun learning and you want to go and explore, maybe do a master's, right? If you want to go for a PhD, go for it, but don't do it because you think you're going to get a whole lot of money. Because the time you invest, you could probably make much more money building up your career in an industry, probably as well. So it kind of it's the same thing.
You can become a doctor, but just not the kind who helps people.
Exactly.
Do we have time? We have time. Just we're a little bit running a little long, but one more quick question for Cynthia. If someone has a burning question, please feel free. All right, go ahead.
What would you say has been like the most challenging thing you've had in your like higher education career? Or, how did you solve it?
You know, that's really interesting because in my career, I was really good in high school and I had really good grades in high school, but I struggled in college a lot. And my grades weren't the best in the beginning of college. So when I got into my concentration of what I really liked, that's where my grades really excelled. So I think it's how you shape the narrative, right? Because I was able to say, okay, my freshman year and sophomore year, my grades weren't that great, but look at my junior and senior year, and actually my program was 5 years. So most people knew that that program at the time through the business school was a 5-year program. And in some cases, for some people, it was 6 because the classes were only offered like one class this semester, one class the next semester. So I was able to share my GPA from the last 3 years, and that's where it got me places. So I think it's really about how you shape the narrative. But I think also when you look at challenging things in education, it's really never giving up. I had to retake my statics and dynamics class because I didn't pass it the first time. One of the classes, because it was in the program of manufacturing engineering or mechanical engineering at UT, and I was taking classes at the business school at UT, they didn't specify because it's a very small degree, it doesn't even exist anymore at UT. But at the time in the course catalog, they had one class that was labeled a manufacturing engineering class and one class that was labeled a business class. It turned out they were the same class. So I almost didn't graduate, and I had to appeal my graduation because they told me, oh, the class you took sophomore year and the class you took in your junior year in the business school were actually the same class, so you can't receive dual credit for it. And nowhere did they specify that in the course catalog. Nowhere did any advisors say that. So I think it's always fighting for what you believe is right, shaping the narrative, and not giving up, really. Solving that problem, solving that puzzle in however way you can.
Okay, thank you very much for that, and I think we're pretty much at the end of our time here, so I'd like to thank our speakers for this panel, Cynthia, Marion, and Zach. Wonderful for you to come out tonight. Round of applause, please.